Hello everyone, it's August 14th. Alright, let's do this. Power of 4. Yeah, I think we can use that. So, you know what? Maybe it'll be easier. I think should be 31. Yeah, so $15. That's the value. Alright, so the maximum power of 4 is 4 to the 15. Is this. We just need to check if n divides this value, this number. Well, it will be a power of 2, I think. No, I think power of 2 will not. So if n is smaller than 0, return false. And then return mod n is equal to 0. Oh, I can just say n larger than 0, right? Huh. That doesn't work. I think 2 is a edge case. Alright. Oh, but 1. Shoot. Okay. Alright, if that's a true. Right, return true. So that's a 0 power. Otherwise, it has to be larger than 2. They all suffer from this problem. It's the same thing. So just the power has to be even. Okay, so this doesn't work. So we can we find the power find the power to 2, right? Power of 4 if n is power of 4, it must be a power of 2 with the power being even number, right? With being an even number. So essentially what we first do is we say if n and n minus 1 is not equal to 0, right? The only time it's okay, hold on. So if n is smaller or equal to 0, return false. If this, return false, right? What would be a case that you minus 1? Hold on, let me think. Yeah, it should. That's the only case. Yeah. Okay. Then we need to count the number of bits, right? So number of zeros. 1, so 1, 2, 3. So 1, 0, 0, 0 is 8, which is 3. So you should count p, right? And larger than 0. Right shift 1 and p plus plus. Alright, so for this 1, 2, 3. I think you might get 4 out of it, because you are 1, 0, 0, right? 1, 0, 0, 0. So we'll go 1, 2, 3. Because after 3, you have a 1. So larger than 1 then. And then return p mod 2 is equal to 0. Okay, how about this one? Okay, this one looks okay. Yeah, this one looks okay. Every time we have multiple answers. But actually, it's okay. That's an interesting question. All right, I think what I want to do is, I haven't done a medium problem for a while. Let's go to a medium problem. How do I find? Well, we'll go reverse. Actually, I think I can just go to contest. We go a weekly contest. That's actually pretty good. We'll get a problem out of it. Usually, let's do this one. Just for fun. Maximum k to sort a permutation. You're given an integer array of length n where nums is a permutation of the numbers in the range. You may swap elements at I and j only if nums I and nums j are equal to k. and where and denotes the bitwise AND operation, and then k is a non-negative integer. Oh, okay, this is a bitwise operation. Return the maximum value of k such that the array can be sorted in non-decreasing order using any number of such swaps. If nums is already sorted, return 0. So we say we want to swap such that it becomes sorted, and we want to know what is the max value of k. Max value of k. And you can only swap if the two numbers, if the end of them is exactly equal to k. Huh. Wait a second. Nums 1 is 3. So 1, 1 is 0, 1. Okay, so yeah, the end is 1. So we want to swap these two. Yeah, because you need to swap 0. Since you need to swap 0, and it has to be 0. Hold on. Because you can always swap any number based on some number, right? So like if I want to swap 3 and 2, I don't have to swap 3 and 2. I can swap 2 with 0, 3 with 0, and 2 with 0. Right? We have an intermediate. So with that in mind, so they can always use an intermediate to swap. I mean, so in this case, 0 is already in place. If 0 is not in place, then you have to swap 0, right? Then it becomes 0. If 0 is in place, then you move on to the next one. So basically, this question is asking what is the smallest number that's not in its place, because that is the value that you have to swap. You have to swap with, right? So because for AND, the smaller the number, right, when you AND two values, when you AND the two values, I'd say the biggest one you can get is the smallest value, right? The biggest one you can get is the smallest value. So you find the smallest value that's not in place, then you know this is the maximum value that you need. You cannot get even a bigger one, because if you get a bigger one, this one cannot get swapped, right? And then you just need to be very careful with the swapping and make sure that because it can happen, like let's say 3 is the smallest, right? And then when you end with someone that actually, okay, so basically you have to end that number with everybody else, everyone that has not been sorted. Okay, everyone that has not been sorted, you have to end it, and then among them you'll find the smallest value. But hold a second. It says can be sorted in non-decreasing order. Yeah, so you find the smallest number that's not in place. So you say that number must be moved to the right place. But it doesn't have to go with the current one that's occupying its space. We can do all other sorts of, but each time you do, they might result in an even smaller number, because you can only swap if it equals to that number, right? You can only do that if it equals. So what if it does not equal? Then you find something, okay? Then you find something that can give you that value, right? You find something that can give you that value, and what? You find some value that can give you, yeah, because the principle is you have to move the smallest value, right? So the biggest number cannot be bigger than the smallest value. But what I'm afraid is if everybody is sorted and the only one that's not sorted is the value. For example, I have 3, okay, and I can have a 4, right? So if 3 and 4, so I say 0, 1, 2, 4, 3. Now the smallest number that's not is 3, but k is going to be 0. That's my understanding for this one. So for example, if I do 0, 1, 2, 4, 3, I believe the answer should be 0. Yeah, the answer is 0, because I mean, even if you swap with other things, but if you swap with other things, I mean, like, what's the point of you swapping with other things? At the end of the day, you have to swap 3, right? Or you swap with other things, then you have even smaller, right? If you swap with 2, then you have an even smaller one going into a position. Yeah, you have to swap it anyway. Huh. So you have to swap it anyway. If you pick any other number, right? If you pick any other number, then eventually when you need to swap the smallest, and your number is bigger, then the smallest cannot get swapped, right? So you need to swap. You need to make sure the smallest can get swapped into the correct position. I mean, I have an idea, but I am just not sure if it's valid. My idea is you find the smallest, and then you just end that value with everyone that's out of shape, right? And then you will find the one with the smallest, and then you say that is the answer. But that is based on the idea that, because everybody will, like, if you swap anything, you can swap with that. That's basically the idea. And so but it says has to be exactly equal. Exactly equal. So you have the smallest value, right? Exactly equal. So if someone has something and then someone else has something, and then like they cannot swap, right? How do you reason with that? What if, for example, I have it's not really a good example, but like this is a 0, right? And what if I give a 1 1 0 and a 1 1 1, and they are all in the wrong position? So that's 0 1 2 4 5 6 7 3. Like these are all wrong, right? So in this I will say 0, but that's just 3 and 4. Right, if you do swap, 3 swap with 4, and then 5 swap with 3, and 3 swap with 4. That's how you get 4 into the right position. But you have a 5, which is a 1 0 1, and then this requires 1. Actually, I'm not sure. Hold on. Let's give this another shot. So 0 1 2 4 5 6 7 3. How does that one go? Oh, the answer is still 0. But how? Yeah, I know the solution, but I couldn't prove it. So basically, you need to find something such that it equals 0. Okay. Yeah, you can always do 0, right? So basically you find the smallest, you find something that allows you to like at least, right? Yeah, you say the smallest must be moved to that position, and then it has to be any of the other ones, right? So you say any of the other ones. If you lock down on something, okay, that's bigger than this. Well, it's actually not going to be bigger than this. That's like, it's just like the smallest value. You lock down, say, okay, we're going to have to do that value. Right? And what about the number that cannot do it? Right? What about the other number that's, slightly smaller that they cannot replicate this one? Because it can happen, right? It can happen. It's smaller than that, and then they'll have more zeros, so you just have to give it a bit smaller, right? You have to give smaller than whatever, then you have to go to the smallest one. But the question is, they don't have to rely on this, right? They don't have to rely on this. Like we have something like that, and then the other number are bigger, then we can try to see if we can match to that value. So yeah, I just don't see. What if I swap, let's say, put 6 here and 4 here? I believe the results are the same. Yeah, the result is the same, which I know, but I cannot prove it. Why it is the smallest? It is the smallest. So basically you find the smallest two that has not been put in their position yet, and then you do an and that's the value. Okay, let's say this is the biggest. Let's say we can find something bigger than that. All right, let's just prove by contradiction. If we say we can find something bigger than that, that means those two cannot directly, like at least we have one pair that cannot directly swap. Okay, so yeah, you don't directly swap them, so you will swap something else. Okay, so you can say, I'll swap this with this. Like I do this swap, and then I'll do this swap, and then I'll do this swap. Right? That's how you can, because you have an intermediate. Right, you get an intermediate, then you can swap them. But your AND, the result of your AND might not be the same. Right? The result of the AND might not be the same because you use an intermediate. And if the intermediate cause your AND to be different, then you cannot use this as intermediate, right? That intermediate must make sure that they will be the same. So like this and this will be equal to this and this. Now, for them to be the same, that means this and something, A and B and A and C. That is not possible, right? So you have two smallest number, we call it A and B, right? Two smallest number. And you say that we want to find a K that's bigger than A and B, right? The K is bigger than A and B, okay? So if that's the case, then let's suppose we have a C, or suppose we have a K prime, right? Now we just suppose a K is larger than this, and then we say this is the largest one. Now we have a C and A is equal to this K. That is not possible because A is smaller than C. So the largest you can get is A, right? The largest you can get is A. Now, if A is the smallest, A is smaller than B, then the largest you can get is A, but your K is larger than this, so this is not possible, right? The same with B. This one, the largest you can get is B, but here the largest you can get is A. Therefore, we cannot find a K that's larger than this. Okay, so proof by contradiction will work. I hope this analysis is right. Otherwise, I'll look like a dumb duck. The algorithm is simple. We find the smallest two numbers that are not in the correct position and use their AND value as the largest K. The proof, we can prove this using by contradiction. Say A and B, suppose A and B are the smallest two numbers that are not sorted. Let K, right? Let K be larger than A and B. Be the answer. Okay, be the answer. Then during the swap, there must be a case where some number C must swap with either A or B, right? Must swap with either A or B. Now, since A is smaller than C and then B is smaller than C, C and A, right? C and A must smaller or equal to A, and C and B must smaller or equal to B. Okay. Since A and B must smaller or equal to A, A smaller than B is smaller than A, and a K is larger than that, right? K is larger than K must be larger than A. Actually, I think this is enough proof. I don't need to include the other one. We have smaller or equal to A. Okay. Now, since this is smaller than, we have K is larger than A. Thus, it is impossible to swap C and A because C and A will never equal K. In other words, K must be exactly A and B. Okay, so most likely I won't log in because I need to sort. But if you sort, how do you know which one is out of shape? Oh, I don't have to. I don't have to because it's a permutation. So all I need to do is to find the smallest. So I can say M second M is int max as well. Alright, so for int I, 0 I smaller than nums, not size, I plus plus, okay. if I is equal to nums I, this is continue. Oh, what the hell? This is continue. Okay. Otherwise, we say if nums I is smaller than m, then mm equal to m equal to nums I. Okay. Else if nums I is smaller than then equals nums I. Otherwise, we don't change. So at the end, we'll return m and Okay, let's see. I think these test cases can pass. I just want to see if everything works as expected. Lo and behold, we have an issue. I know exactly why. This will be bad in a contest. Okay, so we have to say if what if it's only one value? Right. If it's only one value, then oh, if it's only one value, then it must be sorted, right? Which means, so if m is equal to int max or is equal to int max, this is where we return 0, because that's when we sort it. So we can use this test case. Oh, I cannot use it anymore. Oh, I can. I think I already added. And also just 0. How about 1, 0? Throwing a few and then just check. Yeah, looks good. This should be good. This is not good. Okay, so I think this is not right. Oh, and not necessarily to be the two smallest one. Okay, that makes sense. It's not the two smallest one, right? It has to be the two will give the smallest. Suppose, okay, A and B are not sorted, and A and B is the smallest n value. Okay. Let k larger than be suppose, right? Suppose this is the answer. Then during swap, there must be a case where C must swap with either A or B. Suppose A is smaller than B. Suppose so A and B give you the smallest. Wait, what's my answer? Output is 2. Yeah, so basically we're saying if we have this as the smallest, some number C must swap with them. Okay. So we say A and B is the smallest n value, and some will swap with them. So k must be larger than A, or k larger than B. Right? And suppose A is smaller than B. We have k must larger than A. I'm not sure if that's correct. Oh, yeah, it is correct because the end always go for the smallest. But the largest value is going to be A, and then k is larger than that, so k should be larger than. But it's that's actually not true. K doesn't have to be larger than A. It's just they're small. It could be 0. Right, it could be 0. Yeah, this is actually not true. This is actually not true. We just know A and B is a value. It's the smallest. And we can say somebody else might need to swap with them. And actually, I don't know how to prove this. Or in other words, how do I make sure that is when you do AND, right? The biggest value, like if you have a threshold, if it's larger than the smaller value, then it will never reach there, right? It will never reach there. So your k, if it's bigger than the smallest value that need to be, then that's, so yeah, you set the upper bound, right? You have the upper bound. And now the question is what, like, so that, yeah, that's the upper bound. Yeah, this is the smallest value, give you the upper bound. But it might not be the smallest value, right? The smallest value need to go, so the big value is actually need to be smaller than that. So now I have some value I can give is, this is saying that if your swap value is bigger than that value, at least one of the swap will not work. Okay, this swap will not work because they requires a smaller value, right? Even smaller than that. Okay, so if they can reach a value smaller than that, right? Then when that value and with somebody else, right, with somebody else, yeah, so like A and B give you the smallest, okay, and one of them is the smallest number, then what we say is, I say A is the smallest, and then A and B give you the smallest end, and this B, right? When this B, we say, okay, I don't end with this. I can try and end with somebody else. But when you end the smallest, it's already getting this value. When you end with somebody else, and you're saying, okay, I'm trying to say you end with somebody else will also be small. It will remain small. You cannot get a bigger value. That's not true. You can get a bigger value. And when you get a bigger value, you end with somebody else, then you get a bigger value. But it will not be bigger than that. Yeah, it will not be bigger than that. So now you have, yeah, it will not be bigger than that. It will be something smaller than that. So if your k is bigger than that, that's also not going to work, right? Yeah, so it's a smaller value, but it's bigger than the smallest that you can get. Okay, then it's kind of somebody in the middle. Then the theory is, whatever it is, that value that you can end, eventually those will have to end with the smallest one, right? They all have to end with the smallest one. And when they end with the smallest one, and because you say you're not doing those two, right? You're not doing those two. So you use those to end with somebody else, right? To end with somebody else. And that somebody else, when that somebody else end with this, so we're saying like they have to give the same k. I cannot prove it. I don't know how to prove it. That is out of position. The answer k must not be larger than the smallest than that number. Then end that number with all the other, right? All the other numbers out of position. The answer should be the smallest such end. However, I cannot prove it. Alright, so hopefully this one is right. I've done too many test cases. Let's remove some. For example, let's remove this. Put this in. Try it. Okay. Oh wow, this is not right either. Ho ho ho. Oh, you put yourself into this position. Wow, any hints? All elements that are not in the correct position. What? Huh. How do I even do that? If I say this is 1, now I end everything. Oh, okay, I can do this. Oh, I can do this. We can say if rest is smaller than 0, then rest equal to nums I, else rest will equal to rest. I can say and equal to nums I. Okay, so if rest is smaller than 0. Alright, this is purely from the hints. But this one's darn hard, man. 3 tries. They're all wrong. Okay. Yeah, but why? I don't know. I don't know. I gotta think about this. Alright, anyway.